All right, so today we're going to find the exact value of this expression, cosine of quantity 2 times tangent inverse of 1/5. All right, so the first thing I want to do is label this part right here, the tangent inverse 1/5. I'm going to label it as theta because technically that is a angle here. Right, any inverse trig function, as long as it's defined, will give you an angle. Okay. So another way of writing this expression, cosine of 2 tan inverse of 1/5, is equal to saying cosine of 2 theta. And the reason I'm doing this is, one, to identify this as an angle, but also when you write it in this form, I think it's easier to see how you go about solving the problem, in the sense of, I can use an identity. I see an identity here, cosine 2 theta, and there are 3 versions of this identity, 3 equivalent expressions, more specifically here. We have 2 cosine squared theta minus 1 minus 2 sine squared theta. And if you have some time, by the way, I'd suggest you try to derive these. If you know one, you can get to the other 2. And just a good exercise. Well, anyways, so I can use either one here. Okay, one has but let me say this: there's some that have advantage over the other ones. I would rather use the first 2 because they only involve one trig function, cosine or sine, and the third one, cosine squared theta minus sine squared, involves both. So I really don't want to work with that. So I'll just work with cosine 2 theta equals, let's say, 2 cosine squared theta minus 1. All right, and this right here is telling us that you're going to take 2 times cosine theta squared minus 1. So I have to find the cosine of this angle that we're looking for, that we have. Okay, so let's go back to the where we let theta equal tangent inverse of 1/5. And before I go on to the computation here, let me say that this angle is defined to be between minus pi over 2 and pi over 2. Because tangent inverse gives you that range. It gives you an angle between minus pi over 2 and pi over 2. And specifically, this angle is in the first quadrant, okay? Because tangent inverse of 1/5 is going to give you something positive, and that means that it has to be between, it has to be greater than 0. So if my range is between minus pi over 2 and pi over 2, or between minus 90 and 90 degrees, then it has to be between 0 and 90. And another way of writing this statement here is saying tangent of theta equals 1/5. And sometimes before even going here, some people just find it beneficial to rewrite this expression as that. And again, they are, you can go from one to the other. Tangent theta does equal 1/5. And from there, I can figure out what cosine is. Okay. How do I do that? Well, if my angle is in the first quadrant, you can draw an angle here, theta here. And I apologize about my drawing. Obviously, I'm not Picasso here. Horrible drawing, so please excuse me on that. Tangent is 1 over 5, or as we know it, y over x. So y would be 1, x would be 5, or any multiple of 1 and 5. Anyways, and if I want to find cosine of theta, cosine theta equals x over r. So what I'm missing is r. So by the Pythagorean theorem, and I'll let you take care of this, r would be the root 26. So cosine theta equals 5 over root 26. And I don't know if Professor Delon wants you to rationalize or not. I'm just going to leave it like this. So cosine 2 theta would equal 2 times 5 root 26 squared minus 1. So it's 2 times 25 over 26 minus 1. 2 goes into 26 13 times. And you get 12 over 13 total. And that is our solution. So let's go ahead and recap, because I think there was a lot going on here. So we're asked to find the exact value of this expression. First thing I want to do is, whenever I see tangent inverse, cosine inverse, sine inverse, whatever inverse trig function we're working with, I want to call that theta. Okay, and I rewrite the statement as, in this case, cosine 2 theta. And again, the reason I'm doing that is because I think it's easier to see a lot of the time what they're asking when you write it in terms of theta. And in this case, or how to get closer to your goal. And when we write it as cosine 2 theta, I have a double angle identity that I'm going to use, and it's those three. And as I said, you can choose any of the three, but I chose the first one. Cosine 2 theta equals 2 cosine squared theta minus 1. And if I know what the cosine of the angle, and then we're good. Now we're given that theta is tangent inverse of a fifth, and as I said, that angle would be between minus pi over 2 and pi over 2, because that's what the range is for tangent inverse, not inclusive of minus pi over 2 and pi over 2. And another way of writing this out is like saying tangent of theta is 1/5. So I drew out the scenarios. I said it has to be in the first quadrant. I used our definition of what tangent is, y over x. And definition of cosine is x over r, so it's 5 over root 26. So we found that out. Yeah, again, we had to do a little bit of work to find r, Pythagorean theorem, but I think that's all right. And finally, we get our answer, 12 over 13. Okay. All right. Well, thank you very much for your time. Appreciate it. Hope this helps.